Hello everyone, I'm Carmen. I'm one of the 3D modelers here at Firestorm Studio and we'll be continuing not with our environment today. So as you guys know, I've been working on this environment for months. It's nowhere near completion, fun fact, but that's fine. We are not going to be focusing on that today. Today will be my last stream for a while. I'm going to be working on other things for a while. So getting to the point here, what are we doing today? I thought it might be a good time to do a bit of a refresher on all things Houdini. What is Houdini? Why do I use Houdini? Why is Houdini awesome? And also just the basic nodes that I typically use in procedural modeling. Some of them I've demoed, some of them I've not demoed, but the point of this is to kind of get over why you use the nodes rather than just using them and not explaining what they actually do. So without further ado, this is Houdini. We've got our pretty setup over here. Very basic. It's what you get when you open the software. Quick note: I've changed only one thing. So I've personally changed the background to a darker color just due to the fact that I find it a bit easier on the eyes and it makes it a little bit easier to see points. Let me actually demo that. I've just pressed D and this pops up our little menu over here. And if you go to background, I've got dark selected. Some people prefer dark gray, other people prefer gray or light. I personally am a fan of dark. Now, once you've got that, you can save as default or not, depending on your preferences. And then to quickly showcase what I mean actually with the, let's say, show what I mean by it's easier to see. You see how on dark background, the point is very, very easy to spot, right? If I press D and I change this to light, yeah, you can see it, but it's, in my opinion, more difficult, especially on the dark gray versus the dark. So yeah, make of that what you will, change it or do not, up to you. Right, so quick note, this is my old file. I'm not gonna go too deep into that. Bottom line is Houdini is the main point of Houdini is to allow you to edit things really easy and really quickly. It does, however, take a lot more time to model in Houdini than it would in Maya. If you want to maintain the proceduralism, the point of making it procedural is, again, you can quickly create iterations of the same thing without having to spend a ton of time. So let's see if I can quickly get an example. Let's go to this one. Going to turn off points and normals and all of that so we don't have something very obscure. If we pop into, I believe it's this one, this is great, but what if I wanted to change something? Maybe I took this to the art director and he said, well, actually, I don't want this at all. I then have the ability to change things. So, for example, now bear in mind might have broken stuff down the line, but we're going to work with it. Again, this is an older file. Well, it's one I've been working on forever and I've not organized it, which I'm very bad example here. My files aren't very organized on a stream just due to the fact I work in a very, very chaotic and playful way, which is brilliant for exploring things and just trying things out, which is the main point of these streams. But the downside to that is it makes it quite a cluttered mess, and that will be another topic for today, but we'll get to that in a moment. Right, so as you can see, I'm just popping in between two options. Maybe they only want one door instead of two. That could be one option. Maybe let's go to the right. I believe that's this side. No, it might be that one. I can also choose how many windows I want. Maybe we want 2 windows, but we want them further apart. Right? Maybe we want 4 windows. But you can kind of, okay, so that is just due to the placement of things. That's why that's popping out. We can just condense that down and that'll fit on the wall. So bottom line is I've got the ability to make all these changes relatively quickly, and if you've set it up correctly, you'll have UVs, textures, everything built in procedurally. That means you can swap between them, and as long as the mechanism is built in, you can make the changes that the art director or whoever wants. Right, so without further ado, let's pop back into our GeoNode. GeoNode is, how am I going to explain the GeoNode? It's geometry. It's predominantly geometry. You can do other things in it. You can rig in here. You can, I'm pretty sure you can even animate in here. But bottom line is the GeoNode I predominantly use for geometry. Right, so that's a little bit about the procedural side of things. Is it something that is utilized every day at a studio? Possibly not, it depends. It's used more on the environment side than it is on the character side. Yes, you could use this for characters to some extent, especially if you're deforming the characters, think shape keys, blend shapes, that type of thing. But predominantly, I would say it's more utilized on the environment, effects, etc. side. Fun fact, I recently learned they're even using it for AI, which is unfortunate. But yeah, that is a whole other topic that I'm not going to be getting into today. So, Geo. We've got Geo. Now, within Geo, we've got a lot of things we can do. And I think one of the topics we're going to be talking about is more on the modeling side. We're obviously not going into effects. That's not my area of expertise. So, trying to think what would be the best. I've got notes here, hence why I'm looking down. Best place to start. We've talked a lot about lines and normals and curve U and all of that. And yes, we could go back into that, but I think to switch it up a little bit, let's quickly build something. So, I'm going to start with trying to think what the best option here would be. Let's start with grid. Why not? We're going to start with grid. Brilliant. Now, for the grid specifically, I want to probably rotate it. So I want it to be facing forward. So we are going to rotate on the x-axis. So y-x, the x is obviously left to right in this case. So due to it being the left to right, I want to rotate on that axis. So we're going to do 90 degrees. Yeah, 90. Now this is too much geometry for what I want to do. So I'm actually going to reduce this. So let's do something like, I don't know, maybe something like that. Brilliant. Now, ideally, I want to do a, let's say, a procedural operation. There is a way of doing this procedurally. I'm just not going to do it procedurally just for the sake of doing this quickly. So what I'm actually going to do is I'm going to select, yeah, let's say primitives. And turn that button on. Is it primitives? Am I crazy? It's not edges. Hello, I don't want to do that. What have I done? I've broken everything. That took me, what, all of 5 seconds to break? Alright, so I want to select these guys. And I'm just going to delete them, which adds a blast node. This is not procedural. This is a very poor example of being procedural, but the point of this isn't the geometry itself. I want to show you something else. So, bottom line is this the best way to show this though? We've got options, but let's start there. Next, I'm going to add a copy and transform. Alright? This geometry is going to get plopped into there. Nothing happens. Pretty normal. Pretty expected. What I actually want to do is I want this to copy to around about there. Now, I know by default the grid side is roughly 10 meters. So in translation, that's going to be 10. Brilliant. Right? So I want to copy that across, and that'll copy all prettily. Now this isn't centered in the world, so I'm actually going to center it using a match size. So, match size, what does it do? It does multiple things. You can use it for placement, you can use it for scaling, you can use it, let me actually demonstrate that. So let's say, by default, it puts everything at the center of the world, which is brilliant. But sometimes you don't exactly want it centered. You might want it centered in the x-axis, but maybe you don't want it centered in the y-axis. Why is that? Now, for those of you that have done a lot of modeling, you'll know, generally speaking, you want your geometry to be flat on the ground, as it is currently, and as it is in Maya as well. In Maya, if you add a cube, it's completely centered in the world, and you have to manually move it up so that it aligns with the grid. So again, x, y, z. So x is left and right, y is up and down, z is front to back. This is for Houdini. Blender has a little bit of a different orientation. I'll be honest, I can't remember which is which. I believe z is up and down for them, and y is back to front, and x is left to right. I could be wrong. Roughly that. Right, so as I mentioned, this is centered completely from left to right, front to back, up and down, completely centered. We do not want that. We want it to be flat on the ground, because that's how we model. If we were copying things around, we want it to be flat, because otherwise it'll clip through another object. I can demonstrate that in a second. Right, so I'm just going to change that to min, and that is now centered. Brilliant. An alternative way of centering, because match size adds an additional node, which is fine, but maybe that's not what you want. So let's quickly void the match size. Now obviously, bear in mind, this would work for centering left to right, but for up and down, it can work. So you can take your height, which would be, am I crazy? Let me just double check. No, it's not. Okay, so this one's up and down. You can copy that parameter, paste it into the center. Now what's the center? The center is where your object is positioned in the world. So for example, again, x, y, z. If I remove x, we move to the left. If I use y, it goes up and down, and then obviously this is front to back. We won't be able to see it because I've changed the view, so we're an orthographic front view, right? So I'm going to zero that one out. Hello, I said 0. There we go. And as you guys remember, I have copied this parameter. Now, if I paste relative references, it gives us this. And as you'll notice, it's actually above the center of the world. That's fine. But before I actually go into how to get it actually centered, I quickly want us to take a look at this. So what does CH stand for? CH stands for channel. So we're looking at a channel. Brilliant. That's fine. Next, we've got size, Y. So that just means it's looking at the channel size Y in this specific node. Now, I've not tested this, but if I'm not mistaken, this will get a little bit more complicated if you plop it into another node. So in other words, if we copy this parameter and paste it into, I don't know, rotation. Yes. Right, so this gets more complicated. So now it's saying, we're still looking at channel. Brilliant. However, we're now also looking at grid 1. Now, if we look up here, you'll see grid 1 is the node. So it's telling it we're looking at the channel, we're looking at a channel rather, specifically related to the node grid 1, and within grid 1, we're looking at size Y. Right? Now, is this relevant to procedural modeling and what we're doing right now? The meaning will help. I'm one of those people that I'll just plop a bunch of things in there and I'll smash my head against a wall until it works. But that is not the best method of actually learning a software or using a software. Yes, you eventually get to the answer you're looking for, but it takes a lot of time and wastes a lot of time. So instead of doing that, it's oftentimes better. Now, I'm a poor example. I've not done it. I'm learning, but I've not done it. Is understand what it does and why it works the way it works. So brilliant. We've got it down. Basically, CH channel. Size Y is which area in our node it's looking at. Right, brilliant. We've got that. However, as I've mentioned, this is now copying this value directly, meaning if I were to scale this up to, let's say, 15, it's moving up 15 meters, basically. Because if let's delete channels for a moment and zero that out, right? Because it started down here and it basically hopped up all the way to there, right? If we undo that, you can see that. Redo. So it hopped up all the way there and basically copied it on top of the top point of the node. Brilliant, not what we want. Now, if you'll notice, what is the center point between this one and this one? 0.5. It's half. Of course it's half. So, if our height is 15 meters, we want, what is that, 7.5? But if I were to manually put 7.5 in here, brilliant, it's centered. However, if I were to scale this, it's no longer centered. That is the point of doing it in a way that, let's say, it looks at other things. So I explained that very poorly. So let's start over there. The reason I copy this parameter is that I want it to always refer to the size of the height. It doesn't help to manually place it in because it doesn't change. Well, if it changes, the placement doesn't change accordingly. So if the scale changes, the placement doesn't change accordingly. Right, so that is, again, channel size Y. Again, we're not in the correct place. So what we can do is we can do one of two things. We can divide by 2, or we can multiply by 0.5. Now, some people prefer one method. I personally prefer just keeping it multiply. I know it goes into the decimals. It is fine. I'm happy with that. So what I'm going to do is I'm going to multiply by 5. And if I did that correctly, which, no, I lie, not by 5, by 0.5, right? Brilliant. Now it is actually centered. So if I were to scale this again, it stays in the center. Brilliant. I'm actually going to keep this at 10, however. Right, so that is that. Now again, as you'll notice, left to right is still not centered, and I would not recommend using channel referencing to center left to right when you are copy and transforming. There's an exception to that. Let's say, okay, you're not using copy and transform. And this is the scale of your object. Now, by default, it is centered, but let's say you want it similar to the bottom where you maybe wanted to sit over here, right? Then you could do the same thing. You could take the width, plop it into the center, and multiply it by 0.5, right? And then that'll center it that way. Right, that does work. But not when you're making your entire object bigger down the line. So again, 2 methods. For just the overall centering in the world, using this channel referencing is fine. You already have the node, the data is already going through everything, so they thought it would technically be more optimized to use your grid node because it's there, the data is already there, it's already giving you all the information. So let's actually, on that note, take a look at the geometry spreadsheet. So let's do geometry spreadsheet. Right. So as it is currently, we've got, let's look. We've got 16 points. Now, points come with a lot of attributes from the start. You've got normal, and you've got position. There's maybe some other information that comes through as well, but the important ones are position and normal. I'm not too concerned about normals. Generally speaking, geometry will come with normals. I'm not sure whether grid specifically does come with normals by default, but it doesn't really matter. We're not worried about normals. So, points. 16 points. Okay, not a lot of data, but it's not technically just 16, because for your placement of your points, it's going to look at X, Y, Z for each point. So if we actually look at, let me close that down, our geometry spreadsheet, we can see that we've got 0 through to 15. So 0, 16 points. I'm not going to explain the math behind that, but bottom line is 0 to 15 is 16. Okay? But if you look at it, we've got px, py, and pz. So p stands for point, obviously, and xyz for direction. So point 0 is minus 5 meters towards, so 5 meters towards the left of the world. And then in the y direction, so up, it's 10 meters up. So this tells us exactly where it is in the world, and of course in z it is 0. So z is front to back. Because the plane is flat, there's no value in there. However, the software is still looking at this data. So each point, yes, it's 16 points, but you can multiply that by 3 because it's looking at 3 other channels to determine where it is in the world. Now, Houdini gives you access to this information because you can use it to do things. Brilliant. All other software, Maya, Blender, 3ds Max, ZBrush, any of those softwares have this information under the hood. So the information is there, you just do not have access to it. And then of course you've got point numbers as well, which is these guys, right? The 0, 1, 2, 3, 4, 5, etc. Now, here's where it gets a little confusing. Maya calls a point a vertex. There is vertices, but a vertex is not a point. So by that I mean, if we look at these guys, those are points, and if we manipulate them, they function the same way a vertex would in Maya. So, the vertex in Maya is basically a point in Houdini. But Houdini also has vertices, but they do not function as points. Now bear with. If we look at specifically, I might need normals for this, but let's see. Let's do perspective. Am I gonna need display normals? I don't want those. I'm trying to see if we can actually see what's going on here. Let's add normals. Let us add normals. I need to, let's do it a different way. Let's do attribute create. Hello. Or, no, let's start with spear. Spear has these by default. I am pretty sure. Am I going insane? Because it looks like I am. So point, that's fine. Why is it not showing up? It's being very annoying. Point number is showing up. Why isn't normal showing up? Polygon mesh, primitive. Not looking really at primitive at the moment. We could do... it should have normals. Why doesn't it have normals? Am I crazy? I was so confident in this demonstration until Houdini decided to Houdini. I suspect it's just not showing up. Let me plop over down here. I want normals to show, pretty please. Why aren't you? Mask point data, endpoint attribute. Don't want P scale, don't want mask. It should show up. Let me try something. Let's split left right, why not? Ghost other objects. No, I don't want to ghost other objects. I want to hide other objects. It still doesn't show up. Am I going crazy? Why aren't you showing up? For look here, we do have N. Specifically on the vertices. So we want technically points. Brilliant. Okay, that's one sorted. However, it's still not showing up on the vertices. Compute normals by vertex angle. I was so confident in demonstrating this until it didn't work. As these things go. Right, so we've got point trails. It's not technically that what we want. Alright, it's not that either. Right, so quick other note. This is the number that corresponds with the face. This is the number that corresponds with the point. And then that would be the vertices that goes with the normals, right? I'm actually going to close this scene view. Let's close that. Right. Now, I'm still not sure why the fucking vertice trails are not showing up. Let's see if I can maybe... Let's use Google. Maybe I can get an example there. Let's say vertex. Let's try. It is one. I found what I want, but it's not detailed enough for us to actually see what's going on. Ha! I found it. I have found it. Right, let's go. Are we going to be able to see this though? Let's see. This might be too small to see, but we're gonna run with it. We're gonna run with it. I'm not quite sure why it's not actually displaying correctly, but that is besides the point. We will be looking at this. Now, this was the environment I was working on. I'm just plopping this over here. Right, so this again might be difficult to see, but around each point is 4 of these green lines. And those green lines are basically saying there are 4 vertices surrounding that point. So that's basically the connection point between the vertices and the points, so to speak. Now, in regards to why it's not showing, I don't know. We need that to be on, technically. And they've got point number on as well. And that is it. and it's still not showing. Let's see. It's really bothering me that I can't see it. That's that. It could be a scaling thing, because I have enlarged my normal directions, etc., etc., etc. But, okay, not important, you guys get the point. Right, so, where was I going with this? I'm not sure, but we're gonna run with it. We're gonna run with it. Right, so, let's plop that over there so we can get that out of the way, and I'm going to pop over to the front. Now again, we can't see normals on this just due to the fact that I have not defined the normal direction. I'm not worried about the normal direction at this stage. So, blast, copy, etc., etc. Right, so where was I? Because I went completely off track. I was actually talking about centering everything. So, bear that in mind. So, bottom line is you can center up and down. I remember my point. The point was, if we look at everything, there's a lot of data within points, within normals, within everything. So, when we're talking about importing and exporting geometry, we've got the points, which has, again, the X, Y, Z information. Then we've got normals. Now, normals also have X, Y, Z to determine where it's pointing, right? So, when we're importing and exporting geometry, if you've got, argument's sake, 10,000 points, you can multiply that by 6 for the amount of data it contains. And not only that, you can add color data to that, you can add, obviously animation adds data as well. Trying to think what else it would include. Bottom line is a lot of information, and that's why importing and exporting geometry, heavy geometry, takes such a long time. Because although under the hood, you've got all this information, and Houdini allows you to access that. Other software has the same information, you just can't access it. Well, you can, but it's more difficult to access, so to speak. So the point of talking about this is actually to make you aware of the fact that you're asking a lot of from software when you're importing and exporting a big mesh. And not only that, this data is what allows the different softwares to import things correctly. So without the information about X, Y, Z, everything is wrong. Take for example, Blender has a different up direction. As I mentioned before, I believe it's Z is their up and down. That means if you're importing a geometry that has Y as the up, you'll oftentimes see instead of importing the object in the correct orientation, it'll flip it flat. And why is that? Point, position. If you flip the Y and the Z, your geometry, instead of going up and down, it'll go front to back because of the point placement. It won't mess up your entire mesh because the X is still X. It's still left to right, therefore it's only flipping front to back. Right, so again, if you've encountered that, that is why that happens, and that's why when you're importing things, they oftentimes give you an option to say Y is up. That way, the software knows, okay, this geometry is coming in here, and all the points that are saying their up-down location is in this position actually needs to move over to the Z channel to be displayed correctly in the software. Now, I've rambled for 20-30 minutes about this, but bottom line is hopefully this will give you a little bit of information about the, let's say, behind the scenes. Right, moving on. Geometry spreadsheet. Geometry spreadsheet is basically just a visualizer of all this data I'm talking about. And by data is data. Data, how do I explain data? It's just data. I'm not going to go into that. Right, moving on. We have got a blast, we've got a copy and transform, all of that. Now, I'm actually still going to use the match size because I want this centered in the world. Moving on from that, I want to showcase a little thing. So sometimes this is very applicable to sci-fi things actually. I've made a brilliant demonstration of this in Maya a while ago, but bottom line is, let's work with this. I believe it's a bend node. Brilliant. So, I'll create a better example of this in a moment, but we're going to work with this as it is for now. Now this does nothing at default, right? So, we do want blend, but we've not actually set a capture region. So, we are going to set a capture region. Let me actually go front view, why not? And we can set a capture region, and that's going to line up. Let me think, how are we going to do that? The easiest would actually be to go 30. Oh, I lie, that'll be 35. And then, because I know this is 35 long, right? And then the same in reverse, so capture direction is fine, capture origin is fine, capture length, I lie, this is not the correct direction. That is in the Z direction, so that's front to back. So we actually want and the X direction, right? And possibly even in the minus X direction. Now, you can put that at 35. Actually, I lie, it's going to be 70 because it's double. Right, so this gives us this, which looks like it's actually doing nothing, but we can actually bend this, right? Now, I would personally argue this is still the wrong direction. I don't want to bend in that direction. So, this is... Do we actually want it to be in the... No. Am I crazy? Which one is it? Right, it's not that one. Let's zero that. We are going to use... Can I rotate this? Let's see. I can. 90 degrees. And if we go here and we increase this value, eventually, probably at the 360 mark, no, not 3,360, 360, this actually turns into a cylinder. Now, this example I've made is probably a poor example of that, so we will build upon this. But why would you want to use a bend deformer to get a cylinder rather than actually using a cylinder? Well, the reason for it is modeling is always easier flat. I can promise you, cylinders are difficult to work with. It's more difficult to select geometry, holding edges are a nightmare, especially when you're doing a repetitive pattern. Or maybe you want to have every second geometry a different one, doesn't matter, but bottom line is when you're modeling complex geometry, having to do it 7, 8, 10 times, etc. is an absolute nightmare. So this is sort of a workaround for that. You can model your geometry flat and you can have a nice result. So let's give a different example. What are we going to do? What are we going to do? I'm actually going to increase the geo on this back to 10. Why not? Let's do 10 and 10. Right, I'm turning point off just so it's not cluttering up my viewport. And let's quickly create something that is a little bit more interesting. Maybe. Yeah, let's do that. Right. So, as I mentioned, this blast is currently selecting no, I lie. It's selecting face numbers. So, if you remember, we quickly took a look at this. Each face has a number. It goes usually from 0 to whatever the final one is, in this case 80. But you'll notice it's in order 0, 1, 2, 3, 4, 5, 6, etc. However, that's great, but if I change the number of rows, you can see, actually, let me do it in this direction. The placement changes. Let's say 5 is over here. If I were to move this, 5 is now over there. So if I specified, well, I want to delete face number 5, and I later went down and said, no, but I'm going to change the rows and the columns and all of that, 5 is going to change location. Therefore, the one I'm blasting out is no longer correct, which is one of the reasons I mentioned that you shouldn't select faces manually, because the faces that are deleting are based upon face number. And if you change anything, your face number changes. In fact, we're blasting out, so blasting is deleting 0, 2, 6, and 8. Brilliant. If we look down here, we've now got a new 0. 0 was towards the left, we've deleted 0. So now now 0 has moved to the right. And you'll notice that yes, we've blasted, but now we still got a point order and still going left to right. So it's still going 0, 1, 2, 3, 4, 5, 6. But it's skipping, obviously, over the areas that have been deleted. Which is fine, but that means things have changed again. So let's avoid that. Now, one thing that can't be avoided, right, is if you delete something, the primitive number will change because it doesn't want blank numbers. It always wants to go 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. So if you delete 9, it's going to assign 9 to a new face or to another face. So great, not what we want. Again, you can't avoid it after the blast, but what you can do is you can keep the blast functional. So I, for example, always want, argument's sake, the bottom face to be selected, or the bottom row of faces. So how can we do that? Well, there's a few ways. The first is we can manually select it, which we've done, and we now know that if you manually select things and you change the rows and the columns, well, it's no longer functional the way we want it to function. So that is out. Our next option is a group, right? Now, I'm thinking of one of two groups. Either group by range, which we'll get to in a second, and it would be my preferred method depending on what I'm doing, but let's say it's my preferred method. Or we could do a normal group. Well, I say normal group, I mean just a standard group. Obviously, let me get the node and I can explain in more detail. Alright, we've got the group node. Brilliant, fancy, whatever. Group. Now, what is a group? It's basically a way of selecting things in a procedural way. However, you can make this non-procedural as well. You could, again, go in and manually select these guys, why not, and say tab a group, and it'll actually group them for you. But again, this is based upon primitive number. So in other words, the number that corresponds with the face. Again, non-procedural, and in fact you can see the face number over there. Brilliant. Again, we do not want that. So by default, if we group something, it'll be set a primitive. What is a primitive? A primitive is, in this case, a face. You've also got points. Again, we've talked about points. It is basically a vertex in other software, but they call it a point in Houdini. Point is technically the correct term for it. However, other software tend to call it a vertex. Right. Then we've got edges. We all know what edge is. The edge is the edge of a face, basically, that defines the faces, so to speak. And then we've got a vertex, which we cannot visualize at this stage. But the point is, vertex, there are four vertices for every point, or in this case, on the corners, probably 2. Because it's a connection point. Right. So, in this case, we want primitives. Fancy. It works. However, it's now selecting everything by default. We do not want to select everything by default. So, we have got a couple of options. We've got bounding regions. So, bounding regions is similar to what we did with the bend. It's a capture region. By default, the bounding region is black. Right? Now you've got one of 2 options. You can plug a geometry in here. And is that how it works? No. Yeah. So you could do, let's say, argument's sake, let's do, is it a cube? I think it's a cube. Let's do cube. You could do cube. Plop that into the bounding box, bounding object. I've broken everything. Bounding type. Am I wrong? Partially contained entities. I think I'm wrong. Okay, let's ignore that for half a second. Right, bounding box. Keep in bounding region, fine. So bounding box is a box. That is what it is. That is all there is to it. By default, let's just quickly get another node because I've broken some stuff because I've initialized. Right, so let's plop that into there. Brilliant. So again, you pop into here and say keep our bounding box. We can actually see the bounding box. It's the size of a cube by default. Brilliant. However, if we say initialize input bounds, it actually takes the scale of the initial object, which is the grid. However, that's again selecting everything. There's a workaround for that. You can manually change it. And now it's only selecting the center faces, and this is a fun way of doing things because you can also reference the, let's say, the center point. You could zero this out and it'll select the bottom. All of that stuff, you can play with it, right? So that's one way of selecting. You can do it by bounding box, and you can alter this. However, as you'll recall, we used initialized input bounds. That's great. However, it's not technically procedural. By that I mean, if we were to change the scale on this, that doesn't change accordingly and we need to reinitialize. Which is also not what we want. Now, I can refine this in some ways, and I will go over that in a second, but let's move on. That is bounding box. It's just bounding a region. It's just a way of selecting within the parameters of scale, basically. So, let's turn that off. The next option, now this will be difficult to visualize on the grid, so let's actually grab a cube. Plop that into there. That goes into there, and then we are going to keep our normals. Brilliant. As it is currently, it's looking at the front to back. So, z-axis. Brilliant. However, it technically looks like it's selecting everything due to the fact that it has a 180-degree spread. If we were to decrease this, you can actually see that we can use this to select only the front face. Alternatively, we could select only the back face using the minus function, right? Alternatively, we can select both. If we want only the ones facing the front and the ones facing the back to be selected, we could use normals. Alternatively, we could select only the top and the bottom, or, of course, left and right, or only the left and only the right, depending on what you choose. Now, as it is currently, I've included the X and the Y axis. And what that does is it kind of finds the midpoint, which takes us to the next topic, which is, what do you call it? A vector. Now, most of us learned about vectors in school, so there is that. So, vector is, to keep it simple, direction. So up, down, left, right, that gives us 3. So these are vectors. And basically, if you combine X and Y, it's going to find the middle point between up and to the left, or to the right, depending. Right? So if we have like a square, and you take the middle point, let me see if I can, yeah, it'll be around about there. It'll be the middle point of that. I'm explaining this very, very badly, but bottom line is that is what it's doing. Right, so that's normals. And then, and to visualize what a normal looks like, should we visualize that? No, we're not going to do that. Then you can include by edges. I never use this. Let's skip over that. And then random chance. So random chance basically just selects random faces. Randomly. Selects faces randomly. So there is that. And then, right, so we've got that. Now, the one we want to utilize for the plane specifically is not normal. Normal will select all the faces toward the front, and we won't get anything interesting. So what we actually want is what you'd call bounding box. However, as we've established, bounding box is brilliant, but it's a variable. Or it has variables, rather. So what I'm actually going to do is I'm going to look at the width of our plane, and I'm going to copy that into the X scale, right? Again, this is looking at the channel, the node, and the specific area of the node we want to look at, in this, or a specific channel within the node we want to look at, in this case, size X. That now means if I were to, I want to scale this while viewing that, that's probably impossible. Let's say, maybe we can do it that way. No? Okay, brilliant, we cannot. So, but if I was to scale this to, let's say, 15, you can see it adjusts accordingly, again, because we're referencing the channel. Brilliant. Moving on. So I do want left and right to be selected. The next area of contention is I don't want this to be below the ground level. So next thing I want to look at is this channel. So I want to copy the parameter for height and I want to paste it into the center. And as you will remember, we want to multiply this by 0.5. 0.5. There we go. Now, if we were to scale this, our selection will stay active. Right? Now, the height of this won't stay constant, but that's a whole other topic that I'm not going to get into. So, let's just, can I get this back to size? Fine, that's fine. Okay. We're going to work with this. I actually deleted some of the things I wanted, so I'm going to copy that parameter, paste relative reference, and multiply that by 0.5. Okay? And that should be, why aren't you? Oh, there's a 0. Right. If something is not working, it's 9 times out of 10 user error and not Houdini. Let's leave it at that. So we've got that. Now let's say we want to do extrude that. So let's do a poly extrude. Why not? And by default it extrudes everything. But we've got a handy dandy group. So we can quickly rename this group. I'm gonna name it extrude. Why not? Let's name it extrude. Just for the sake of organization. Right. So that still does nothing because we've not specified the group up here. So now we have, and in theory, if we're to extrude this, that should work, right? So we're going to grab that. That's going to be our extrude. And then we can also make this more complicated. So we do have the extrude, and that's all well and good and pretty. But what I actually want to do is I want additional extrude. But I don't want to do group extrude, group extrude, group extrude. So I want them all to use the same extrude. Now, there's a variable to this. If I wanted a different extrude amount for each group, I wouldn't be able to do this. But since I do want them to be connected or extruded the same amount, I am going to do it this way. So I want to remove this channel because I do want to adjust the width. Right? Do want to adjust the width, and I'm going to plop this maybe up. I want this like that. I mean, why not? Is it going to override these though? Probably. Okay. So it's going to override. So I'm going to name this extrude 2. Right? So I want to extrude, and I want to extrude 2. That gives us this, right? So that's kind of building on top of each other. However, I also want extrudes that are a little bit more random. Well, not a little bit more random, but maybe a different amount. So what I'm going to do is create another group. Now, we could also do... What we're going to do within bounding region? Yeah, let's do within bounding region. I'm just going to do something relatively random. Yeah, why not? So let's adjust the scale on this. And I'm going to... Do I want to go up and down? No, I want to go left, right. Well, yeah, let's go up to down. Right, so I want to maybe... I did make it large in the height, but I actually want to go maybe something like that. Let's move maybe a little bit down. I actually only want those two maybe. No. Okay. Thinking. I think I'm gonna go this direction. And we'll have to scale a little bit in height. There we go. Let's say I wanted to extrude that piece. And I could do, let's name it extrude 3. Why not? We're being very descriptive here and unorganized, but bear with. So we're going to do 3, and then we are going to do poly extrude. Right. So again, we need to specify the group. And then we can actually... Do we want to make this more interesting? Yeah. Okay. Do something like that. We could do a twist. Do we want a twist? Twist will break at this level of geometry, so let's leave the twist. Okay. So we've got our interesting piece that gets copied across. Let's say it was very complicated. This isn't, but for the sake of the argument, let's say it was. We get that. Brilliant. Again, centering it, and this gets bent. Now, as you'll notice, the bend unfortunately does move it. I'm not sure if we can mitigate that. Could we? Probably not. What happens if we zero this? Okay, so zeroing gives us that. We could keep it at -1. There's a way of capturing both directions. Deform in both directions. Okay, so this is now somewhat zeroed. What I'm not loving, however, is the fact that this is not centered in the world. Now in Maya, this would have been centered. Could we? What does this do? That okay? That's up. It's left to right, front to back. Okay, so none of that's going to give me what I want. It's fine. We could use a match size to recenter this. Right, so that is an option. But let's leave it at that. Bottom line is we get the cylinder. The cylinder, however, is quite boring. So we can build upon this. Now again, so our bend function is a deformer. It's a little bit, it's probably closest to a modifier in Blender. It is a deformer in Maya. I'm not quite sure whether it's called bend, but I think it is. So there's that. I'm just quickly going to change the height on this. Which one is it? I think it's not that one. That's going to be this one. Bear in mind, I've not taken the height into account on this. So we'll have to adjust our groups. Specifically this one. So let's do 15. Why not? That doesn't quite go to the top, but I'm fine with that. Right? Right. So again, we've got this. It gives us a pretty cylinder. What more can I say? It's a cylinder. However, we can build upon this. So let's do... What are we going to do? We can do... Is it flare? No? Taper. Okay, so a quick note on these deformers. By default, they do have a name. Maybe bend, maybe taper, whatever it may be. However, you can access them all within the same node. This is just a preset. You do have the option to change any of them. You can take a taper and then change to a bend to get the bend function. You can even, if I'm not mistaken, use both within the same node. However, I personally prefer keeping these types of things separate. Right, so quick note about the taper node. You need enough geometry in order to taper. So let's go to the front viewport and capture region. So we will probably be looking at the up vector, and our capture region is going to be our capture region. Our direction is going to be up. So that is again going to be up and down. Capture length is going to be based upon the height of our original. Let's get a cleaner number. Let's do 18. Why not? It's going to be based upon the height of our cylinder. So I'm going to paste relative reference. It's going to be time 2. I don't like that that moved up. Why did you move up? Let's see. Capture origin. Is that going to have to be multiplied? I hope not. Let's quickly undo that. What does that do? No, that goes to the top of it. Right, let's see what we can do about this. So now, is it capture length? Is it capture length that I want? Technically, yes. I'm just not sure why it's scaling up. Right, so we want that to be technically 0. This, let's see what it does at 18. It moves up. Why does it move up? Squish. Okay, it technically works. Right, so taper obviously tapers, squish does this. You can change the pivot point and get different results. Basically, you can play with this and manipulate it to your heart's content. Maybe you want something like this. Now, bear in mind, this is moving. We'll see why in a second. It's not deform in both directions. X and Y. Remember what I said about you need to work in the center of the world? What's not currently at the center of our world? Our cylinder. Right, so what are we doing? We are just going to use a match size. I don't want it to go down, so I want nothing to happen there, but I do want it to be centered, and therefore, when I do this, it should work fine. In theory. Let's see what's going on here. Capture length is fine. Why aren't you doing anything? Oh, X and Y is not enabled. Brilliant. Right. So, let's say this was a sci-fi something. I quite like that shape. Yeah, let's do that shape. And this would be one, right? So, but maybe I wanted to plop another on top. Or we could, do we want to keep it like this? Do I want to play with it more? We've got options. Maybe we do something like that. I'm unsure what I want. Okay. So we can do that. And this is all built with a grid, some extrudes, and 2 deformers, and you get a cylinder from it. Brilliant. You've got that. You can also build even more on top of that. And let's do twist. Why not? I might not have enough geometry for this. We'll see. So our up, we're gonna again use the up vector. Our height is probably going to be 18. And we can twist. Right? How much we twist is basically dependent on our geometry and what it can tolerate. The more geometry we have, the more twist it can tolerate. But yeah, bottom line is we could do that. Let's do flat shaded. So we can actually, maybe we can do a bevel. Oh, we're not going to do a bevel. Let's keep it at that. But bottom line is you can kind of see where we're going with this. You've got options. You can play with it. You can have base and then build upon that. The twist isn't very applicable for this specific project, but it is an option. Right, so we could also copy these. Right? So it's using the same base. I'd actually... we can keep it at the bend level. Wait. So, I can then go and say, well, this is great. I want a smaller cylinder. So, in my capture region, I can then maybe adjust. So this one of these. Am I crazy? Why aren't you doing anything? Is it the up vector? It's not the up vector. I believe I was looking at the wrong node. Wait, go back before I break everything. Right, so we can plop that over there. We can go over here. Actually view it this time. And we can say, okay, maybe I want a tall, skinny cylinder. Why not? But I still want to adjust things. So again, we're going to match size to recenter it. The taper will stay functional because, well, quite frankly, how I'm going to put this. The height didn't change, only the width did. And the taper is only looking at the height. Right, so in regards to our first taper, I'm actually going to increase the amount. I want this to go more towards a point. Brilliant. So that can then get plopped up there. So I want this to eventually go on top of that. So technically I want this to be slightly bigger than we've currently got it. So I'll go to the bend and I'll make it a little bit larger. Maybe that much. Right, so this will technically, in theory, fit on top. But our cylinder shape is quite boring. I want it to be different. So we could do, what are we going to do? We could do an hourglass shape. I'm in two minds about what I want. We could just flare it out. We could taper it in and flare it out. I want a different shape than we had. That could be fun. Don't want it to taper that much though, so let's do something like that. Right, then I'm going to use a match size. I could alternatively use the scale of the original plane to determine this, but to show a different method, we're going to use the match size. Just going to plop that over there, and this goes into there, and that goes into there, and this does nothing. So what I actually want is it Minimax? Trying to think here. Why aren't you doing anything? Ha. Right, it's Minimax. I want this to paste on top. Now that's great. Our main geometry has now disappeared, so we can do a merge, plop that into there, and we've got that. Now again, this is made with the same geometry as the base. We can even add another segment to this. So let's keep that part again. And in this case, I actually want the opposite effect. I want it to squish a little bit. Maybe do something like that, right? Then I'm going to use another match size. This time the scale is going to be determined by the size of the merge, right? And I'm going to grab these, plop them over here, and plug them into here. Again, things have disappeared, so we didn't have to do another merge. That gets plopped into there, that gets plopped into there, and that goes like that. Now, we've got a little problem here. It's not lining up, but it is Houdini, so we can adjust things. So, I've got one of two options. I can either make this top piece larger, or I can top piece smaller or the bottom piece larger. In this case, I think I'm going to make the top piece smaller, so it lines up. Right, so we've got that. I would personally want another of the same piece, so I'm going to do that, but for this one I'm actually going to remove the taper. So let's grab that, and we are going to do another match size based upon that, and that goes into there, and that goes into there, and we're going to remove the linear taper, and that gets merged. Right? That gets plopped into there, that gets plopped into there, that goes there, and that is too big, so we're going to shrink that down. So let's do a bend. It might be an in-between number there. Let's do... I don't think this is centered. Why isn't it centered? I don't know. Bottom line is we've got this being functional. But yeah, you can kind of see how we can choose one plane to really build upon, well, everything. So it's useful. It's fun to play with, and you can get relatively quickly a quite interesting result. And then if somebody were to say, well, I actually want a different shape on the bottom, you can then go back and say, okay, well, I can do that. I can go to my linear taper and I can say, well, I want this to look more like that, more the same as the top, or I can say, well, I actually want to squish this in a different direction, and maybe I want that to, I don't know, look more like this. Bottom line is, you can change it, you can play with it, and have fun. Right, moving on. That is one thing you can do with it. Alternatively, what else can we play with? We played with deformers, right? We can play with deformers. And we've chatted a bit about data and attributes. We've done groups. We've not done a group by range. So we can actually, let's take a look at the group by range. So, what's going on here? We've made it taller, it's fine. It's fine. Let's grab that. I'm just going to create the duplicate and then we can do a group by range. Group by range is a pattern selection node. So bottom line is you can plop that into there and you can select a pattern. By default, it selects everything. It's set to primitive also by default, which is brilliant. You can also choose where it starts. This is set to primitive, so therefore it's looking at primitive number. So if we say only start from the 10th primitive, it'll do that. And we can also say, well, only look at the first 10. Or, well, up to 10 or whatever. Bottom line is, you've got a thing to play with. Now again, by default, it's set to select everything. But you can change it so that it selects every second one. And you can, or every third, fourth, and so on and so forth. But at some point, your pattern somewhat breaks, depending on the value, right? So this is looking at it as, okay, everything selects. This selects every second one, but at some point you run into an issue. This is every third, but it actually will struggle to select every fourth because the pattern just won't line up. So that's why it's going crooked at some point, right? Every sixth, it'll select just one, and so on and so forth. The downside to this is it kind of has a default direction, so in this case, left to right. It's not quite ideal. I've never been able to quite figure out why it only selects left to right and why I can't change the direction. Hopefully eventually there will be an option to do that. At this stage, as far as I know, there isn't. You can maybe, I'm not sure whether rotating will actually make a difference, but let's try rotating it. If rotating it helps, I'd say it's probably based on the up direction. Could be normals. Let's Google it. Let us Google it. Let's go. Well, determines the direction. Group by range. Selects. Houdini. Right. We're going to get an AI response here. By the input order of points or parameters, the index and number, the index 0 base range for the selecting a right. is start sort by vertex order and random. Right. Interesting. Very interesting. Let's see. I wonder if side effects will give us a more detailed how to specify the range. So 0 means the first element, the element. Right, so we're going to go back to primitives, aren't we? So, let's undo that quickly. See what our primitive numbers are doing. So technically it's looking at, which doesn't actually make sense, right? Because my logic goes as follows. It should select like 0 to 5 and then from 14 to 20 and so on and so forth. But it's not actually doing that. It's actually selecting every 7th one, skipping, and then selecting every 2. It stays to 7 though. So it's not selecting 1, 2, 3, 4, 1 through 5. It's actually selecting. So if you flip it, trying to figure out the logic here. If you flip it 90 degrees, not 990, 90. Right? If you flip it, it still has these values. Now, how am I going to explain the logic behind this? I mean, I understand the logic now, but I don't know if I can explain it. Let's actually take a look at primitive numbers. Maybe that helps. Bottom line is, it's not determined by direction. It's actually determined by primitive or point number. It depends, because this is currently looking at primitives, but you can also look at points. So in that case, well, points. Right, so let's keep it at primitives. Let us keep it at primitives. Bottom line is you get the different selections. Okay, so let's say you had the group and you wanted to do something with it. Let's say extrude. You could. A prime example of this that I've actually used is with cylinders, not with I've broken something somewhere. Let's see. Every second one is fine. Invert range should probably be turned off. There we go. Right, I've covered the next type of group, which is the group by range. What can we talk about next? What can we talk about next? We can talk about Boolean types, but Booleans are quite boring. Very useful, but quite boring in the sense of there's not much to it. Bottom line is you've got the different types of Boolean types. This is standard to every software. So bottom line is Booleans are a way of combining data from two different objects, right? So when it's said to subtract, which is probably the one you'll use the most, is you're subtracting one geometry from another. If you combine the two, you get a cutout, basically. Let's grab a cube. Why not? Let's demo that quickly. This one I'm going to make large, and then the other one I'm going to make small. Why is this set to wireframe? Oh, it's not selected. Brilliant. I'm just manually going to plop these into position. No, that's up. Let's go forwards. Why not? Alright. So we can say subtract this geometry from that geometry and we get this, right? Get a cutout. You can also flip it. In this case, it won't work very well, but basically it cuts out the shape of that cube. Brilliant. That's subtract. Then you've got union. Union combines two objects. So if you've got here that you want to combine, and then maybe you want to bevel this edge here, you can. Then you've got intersect. So this is a bit like the reverse of subtraction. It basically selects the area within the mesh. So if we go back to subtract, you see this piece of geometry. This is obviously where the smaller cube is intersecting with the bigger cube. So it's basically giving you the geometry of that interior, right? Then you've got shatter, which basically just cuts the geometry up based upon the second input. Lastly, we've got seam, which gives you the edges of the, I say lastly, there's a few more. It gives you basically just the edges that are the connection point. That's probably the easiest way to determine it. Detect and resolve, I quite frankly never use. Resolve, I don't see the use of it. Somebody with more experience than I do will probably be able to explain the mechanics behind it. I've never used it. I rarely use union. Have I used union? I have used union, but not often. Intersect, I forget exists. It's there, never use it. Subtract is probably the one I use the most. It's the one that I build everything upon. And then shatter, custom, seam, detect, resolve, those ones, they're there. I never use them. You can. I encourage it. They're useful. I just don't use them. There's no other way to put it. Right. So that is that. Now, let's say we've got our node network and it's functional and we're happy with it and it's all well and good. This cannot be handed off to somebody else as it is. They're going to have trouble with it. They're not going to have fun working within your files. It's a cluttered mess. So, first thing I'm going to do is I've pressed Shift S. That determines, well, basically to change the flow of the nodes. Everyone has their own preference with this. I personally prefer this type of shape. Brilliant. So, I want somebody to be able to change the scale of the grid. So, that I'm going to keep. And I'm going to make a little note off to the side. That's not a note. This is a note. And I'm going to say scale segment. Why not? Scale segment. In where are we scaling in? We can't scale in the. We could scale in Y. That won't break anything. I lie, it will. But we can make it so it doesn't. So we're going to say scale Y, so Y is the height. And we can also scale in width. With one caveat. But let's say scale Y and scale X. Now we could alternatively place a controller at the bottom where we can scale this from, so that way you don't have to bother with these, but we're gonna work with it, right? So we can scale Y and X. Brilliant. As it is currently, this extrude is referencing the width, so therefore this will stay functional even if we change the width. Not worried about that, right? Then we've got the extrude that's going up and down, or vertically. This one is a little bit more tricky because, as you'll notice, we've manually inputted the scale. Brilliant. Now, as it's currently, we aren't basing this upon anything. I entered a random value and I was happy with what it selected. However, that is not ideal for scaling in general, so if I want the ability to scale y, I need to base this upon something. So what I can do is I can take the y scale, paste that parameter, and let's say multiply it by 0.8. Then it'll always select an eighth of the face. Right. Sorry, my sound died. Alright, we're back. We're back. Okay, so it'll select roughly 1/8 of the faces in that direction. Right, brilliant. That means if we now change the scale, our extrude will stay functional. Let's just view it from this angle. Again, if we scale it up, it'll continue selecting. There's a little bit of a jumping thing going on there, but I'm not too worried about it. Then obviously width stays functional as well. Brilliant. We can scale X and Y, and we can technically adjust the segments. So let's say, let's scale X and Y, and adjust. Adjust segments. Why is there a gap there? I don't like that very much. No. Right. Right. That's slightly annoying. I want that to... Right. Okay, good enough. Right, so we can adjust segments from this point. And the next one is the groups. We will not be adjusting anything in the groups. The groups are just groups, so we can leave that. The next area of contention is the extrude. So we can adjust things in this. So we can again say, no, that's not what I want to do. There's a shortcut for this. What is it? Shift P. That gives us our sticky note. I want this to be red. This one, we're going to say, okay, adjust extrude amount. And we can also adjust insert. I could say that we can adjust the groups, but I don't want to make it too complicated. So adjust extrude amount and adjust insert. Right? Brilliant. So that goes with this. Right. Brilliant. We could just say, we can also just say extrude and insert. That might condense it down and make it a little bit less cluttered. But yeah, that is that. Then extrude, poly extrude, that's fine. Basically the same thing here, so I'm just going to copy and paste it. Alright, that's again a group. We're not working on the groups. I'm going to move things down just a little bit. Right, so this is altogether things related to, let's say, the main shape. Let's say the main shape. We could also create another note. And we're going to say this is based upon... Now, there's a way of making the sticky note invisible. I can't remember for the life of me how to do it, but that's besides the point. We're going to say this is the main... Let's say the plane. The grid shape. Okay. In terms of adjusting the scale of this, there's a way of doing it. No, it's not shift. Trying to think what is the control for it. Doesn't matter. Bottom line is just label your things so you know what it is. So this is all related to the grid shape. I'm going to keep that yellow for now. Down here is everything related to the actual tower. So I'm just going to plop a thing here and say shape. Okay, so out of these, what is important? The taper is important. The bend is important. The rest, irrelevant. So therefore, we can go and grab a note and say, okay, we just make space because this is getting too squishy. I do not like squishy. Come on. There we go. Yeah, let's leave that at that. This merges in the wrong location now, but we'll worry about that in a second. Right, so bend. We will not be adjusting the bend, really. Do we adjust the bend? Or did we just adjust the flame? I think we did adjust the bend, so let's add a note there. That's going to be... we won't adjust the bend amount, would we? Probably not. So let's say... scale. But what is that node called? It's going to be... let's actually copy parameter. Can we? No, that's not what I want. Why is it going sticky note? Okay, that's not an option. Okay, so we can't really refer to it that way. Unless no, I didn't copy the wrong parameter. Did I? Just plop that into there. Okay, so technically we want that. Scale. Equals channel origin Z. Brilliant. And then for the linear taper, we can adjust taper, squish, and squish pivot. So let's do a sticky note, and that is going to be taper. I've spelled something horribly wrong here, taper. And we can adjust squish and squish pivot. Brilliant, right? Now this is starting to look like something somebody else can work with. Very slowly, mind you, but it is happening. Right, so that is that. Let's move this merge so that it actually lines up again. Bottom line is, you can see where I'm going with this. You label everything and that allows somebody else to edit it. You can also adjust things with control, and let's actually quickly take a look at that. A null is technically an empty entity. You could use it to center a camera, you can use it as a reference point. I personally like using it as a controller. Some people do it in a different way. There is a different way of doing it, but this is my preferred method. Right, so I'm going to plop a null. In this case, I'm just going to do that. Right. Did I adjust things in a way that I shouldn't have? Why is it? Oh, I did adjust that. Okay, no, that's fine. That is fine. Right, let's look at the null. I'm going to call this control. Probably like that. Now I can take a quick look at things. I could do this for the main grid shape and all of that. I'm not going to bother. This is just for a quick demonstration. So we are looking at scale. So that is going to be one parameter. Then we're looking at three others: taper, squish, and squish pivot. Now, why would you implement a control when you can just jump down into the node and you can adjust things? Well, sometimes a network gets relatively large. I mean, we've got a simple tower thing, and it's already a large network. Okay, it's technically not that large, but it's large enough. So, that's fine. Bottom line is, if you have a huge network, like let's jump into one of my very poorly organized things. If you've got a huge network like this, it gets confusing real fast and you don't want to jump into everything. So to avoid that, you can use a controller. So I'm actually going to make this red, and then we are going to go edit parameter interface. Now, let's quickly think about what we want. We technically want to be able to adjust the width. That's going to be a float because I'm not stuck on specific numbers 1, 2, 3, 4, 5. If I was, I would use an integer. However, just due to the fact that I want the in-between numbers to still be available, I'm going to use float. Brilliant. We're going to label it, what are we going to call it? Scale. Y. Copy, paste. Okay, scale Y. And we can apply that. And you can see it pops up over there. Next, we want to be able to adjust, squish, etc. That's technically also going to be floats. So I'm going to add 3 more of those. One is going to be squish or taper. Taper. Alright. Apply that. We want squish. Alright. Apply that and squish pivot. Brilliant. And apply that. Accept. And this does nothing. Of course it does nothing. It's not referencing anything. So we can take scale Y, copy parameter, and plop it into the bend. And what's that going to be? Capture origin. And that's going to be in Z. That's Z. That's Z. Let's quickly edit that. It's not Y. That's going to be Z. I'm just actually going to change this. I'm going to change it to width. That'll make it clearer for anyone else that's working on it, what it's actually doing. Accept. Right, so what we're going to do is we're going to grab scale width, copy that parameter, and plop it into capture origin, paste relative reference. Right, so what this will now allow us to do is we can squish it, make it smaller, right? Next thing, taper. So I'm going to copy that parameter and plop it into our linear taper, and paste relative, not on, what did I do? Paste relative reference. There we go. Now I remember that one was 0.5. I did like that. I don't technically want to change anything about it, so I'm just going to leave it at what it was. If I wanted to change this down the line, I obviously could. Then we've got squish. So I'm just going to copy that parameter, again looking at what I have roughly, so that's 0.358. So post relative reference, and that is going to be 0.358. Lastly, we've got the pivot, so copy that parameter, plop it into that one, that's 0.864. 0.864. There we go. Again, now I've got something that I can play with. I can play with the taper, I can play with the scale, I can play with the squish, etc, etc, etc. And this all stays functional. So The benefit of doing this is I don't have to search for any of these nodes. I can just control it at the bottom. Right, so I've talked about a lot of things today, almost too much. So I think I'm gonna leave it here for today. And thank you guys for joining me. And I'll not see you all next time because I'm taking a break from streaming. But once I am back, not quite sure when that'll be. We'll maybe continue in the environment, maybe work on something else. But yeah, enjoy the rest of your day, guys. Bye.